Hi guys, my name is Marco Ruffino. I'm one of the co-captains for the LTU Supermileage team. We're located in the ARC, which is behind the field house in room 106. So I'm going to take you a little tour of our lab. So this is currently the 2019 Supermileage vehicle that we have on display. Come on in. So the lab is very messy right now. We're nearing all the end of our milestones and deliverables, trying to get our running vehicle and get prepared for competition. So for those of you who don't know much about LTU Supermileage team, we're essentially a high performing vehicle that we want to achieve the highest miles to the gallon, and top teams in the competition near 2,000 miles to the gallon. The LTU Supermileage 2021 team is averaging about 700 to 800 miles to the gallon. We feature several types of carbon fiber layups. This is the hood of our vehicle.
The 2021 LTU Supermileage vehicle is a monocoque chassis reinforced with Lantorsork and honeycomb Nomex. This is a two-piece chassis that utilizes an Easter egg shell effect to seal the top and bottom shells together. An easily accessible exit hatch was implemented with hinges to allow the driver to get in and out of the vehicle in the necessary time frame. A carbon fiber panel reinforced with foam core was added to this year's vehicle to help decrease flexure when the driver is laying down in the car. A vacuum bag seat was also added to provide support to the driver, as well as provide more structural integrity to the vehicle. Increased visibility was a focus for this year's team, so a larger windshield was thermoformed and fit into the vehicle to provide ample vision, as well as meeting all SAE design requirements. Along with this, larger side windows are implemented to make sure the driver can see through the rear view mirrors easily.
This is the final design for the 2021 Supermileage electrical subsystem. We have two sub-circuits making up the entire vehicle: the EFI and brake sub-circuit, the starter circuit. Every single circuit was integrated with different wire coding to make wire identification much easier for future edits or anything else we might need. The first circuit is the EFI and brake circuit. This is the low voltage and low amp circuit. It goes from a little battery up to a fuse box. This is where it breaks off into the individual brake and EFI circuit. Coming to the front, the EFI has a single kill switch for the driver. In the back, there is an external kill switch at the top and in the back for any incidents that could happen in the track. The brake circuit comes all the way around to the front to the brake handle here. So when the driver presses the brake handle, the signal will be transferred back to the back of the vehicle and ignite the brake lights. The secondary circuit is the starter circuit. It is hooked up to a high voltage, high amperage car battery. The low voltage section of it travels up to the front of the vehicle to a starter button. The starter button will, when pressed, flash the indicator light saying the vehicle is started. When the button is pressed, it will also travel back to the back of the vehicle and switch this low voltage to high voltage relay, which will then take the high voltage signal wire and turn the starter motor, igniting the engine.
First, going to give you a short overall video on basically what we've done on the engine for the 2021 Supermileage team. So the first thing we're going to touch on is we have our horizontal exhaust. You can see the diameter of the pipe gets a little bit bigger right here. That's to limit back pressure through the exhaust system. So now we'll come around to the other side here. We have electronic fuel injection kit, which is basically this big wire harness up here in this fuel system. So what this is going to do, it's going to let us map the engine with different RPMs so that we're able to put in the exact amount of fuel that we need for whatever speed we're driving at to make sure that we're getting peak efficiency. And so we're going to be using this iso-octane right here, which is 100% octane. Has a much higher fuel knocking rate than regular gasoline, which is us going to put more compression within the combustion chamber so that we're able to get a little bit more torque per fuel input. So one of these right here, this is our modified piston. It's kind of hard to see here, but you can kind of see how it's got this little elevation lip on it with a couple of valve cut holes. They're kind of tough to see because they're pretty shallow. But this is the piston that we're going to be using. It's going to increase that compression ratio from that stock piston from 8.5 to 1 up to 12.5 to 1. So putting all those things together, we'll get this engine running with powertrain and everything else. We're hoping to get right around 800 miles to the gallon.
Today we're going to be talking about the powertrain system and breaking it down for you guys. Our newly designed powertrain system for 2021 team is composed of a jack shaft system. The jack shaft is to implement the direction of the motor to the rear wheel. We have a 34 tooth gear going into the jack shaft, followed through an 18-inch running back to a 52 tooth in the rear. We have a cassette hub here set up in the rear and an aluminum made jack shaft. Our overall gear ratio is 9.75 to 1 for this year, and we're really excited to see how it works.